So as you heard, today we're going to talk about repairs. And my target today is to make your repair skills better. And if you have never tried, make you wish to start trying. So what I work as an hardware designer since a lot of time now. And I basically bring ideas to products. And I am an arcade fan and loved arcade machines since I was born, basically. So here I am, marrying the two worlds with the arcade repairs. Today we're gonna talk about beginners, what they do, what issues they make in starting repairs. We're gonna get a little better approach, and in the end we're gonna investigate the tools that anybody would need to start doing serious repairs instead of just trying and changing parts without getting too much success. So I guess everybody has had this kind of situation. And what happens when people get in this kind of trouble? It happens this. So obviously we want to be on the right side of the picture.
Yes.
So let's see how we do it. Typically the people on the left side of the picture work like this. They get on the forum, they vaguely describe their opinion, they seek an immediate solution, of course, and no chance they're going to accept everything that sounds vaguely complicated. Why? Because they do not want to ask professionals. So it's better? Okay. Because professionals are expensive. They wish they could repair boards on their own, but they actually can't. So what they do, they add further damage to a situation that better, okay, to a situation that's already a problem, and they end up doing this. So either abandon the board or sell it for lots of money, which makes all us arcade collectors quite angry. So let's start talking about capacitors. If you go on forums, everybody will tell you, yeah, replace all capacitors, because of course they are to blame. I do not agree, and that's the reason why. These are some of the reasons that damage capacitors. And these kind of issues are typically found in monitors, are typically found in power supplies, are typically found in all those places where you have a lot of heat and you have unfavorable conditions. So what we want to do instead is to look for these signs. Do capacitors express these signs, then they need to be replaced. Of course, they've bulged, they have leaked, they have exploded, or maybe they look totally fine, but when we measure them, they are out of specification. And the most important measure you will use to really prove if the capacitor is going to fail anytime soon is this ESR. There are meters which you can buy for extremely cheap that allow you to take these measurements. We're talking about 15 euros. So if you want to really change capacitors, buy yourself an ESR meter. Another common pitfall that people fall into, they go on forums and they suggest, they check if there are Fujitsu chips, and if there are, replace them all, by all means. Because Fujitsu chips are notorious for failing. But if on an arcade board there are so many parts that if you start replacing all Fujitsu branded parts, it's gonna cost you so much, you're gonna regret it in the end. So But did anybody ever tell you why they fail? I guess they didn't. And this is the reason why. So this is the cross-section of the chip. And you can see that it has the metal frame with the pins. It has this die glued onto the metal frame, and there are bonding wires reaching out from the pins to the die. Now, back in the 80s, those wires were made of aluminum. Nowadays, they're making out of gold. And in order to save some money, they created some resin, so the black compound, in which they put some fillers. These introduced impurities, and these impurities corroded the aluminum wires. So by being corroded, they actually eventually snap. So the chip is perfectly working, but it's actually unconnected. So you have to throw away the part. So that's the reason why. And of course, this problem got fixed eventually. Otherwise, Fujitsu would have gone bankrupt, and we all know they didn't. In 1986, they introduced something which is called ion chromatography, a fancy name for just saying, hey, now we're checking the fillers that we put in the molding before we assemble the chip. So in the end, this problem only happens on a small portion of the chips produced before 1986. Let alone, of course, if the chip you want to replace is later than that date. You do not need to change it. Another common myth is, as you have heard, oh, yeah, of course, that's loose joint, reflow the chips. Yes, loose joint occur, especially on SMD parts. But I wouldn't call it reflow, right? Because that's not coming from me. I do not have Windows 10. Sorry. So they call it reflow, but I don't even know what they're talking about. Now, reflow is an automated soldering process they do in factories, and it requires this machine, which of course they don't have. So let's rather call it rework, right? Sorry for being a grammar Nazi, but every time they say reflow, I picture the gigantic device, and I say, okay, well, loose joints, they're vibration sensitive. So sometimes they even are temperature sensitive. So if you heat the board up, loose joints fail. In the end, these are problems that you can even detect by nudging the pin. What I do typically is I take a needle, like a needle you have in any syringe they use for medical purposes, and pass it through the pin with a certain force, but not too much. And if the pin is loose, you're gonna see that it's wiggling. So that pin you need to reflow, or actually rework. So the topic is, do not resolder what doesn't need to be resoldered. So what are solder joints? Why are solder joints getting loose? Because they are in this kind of environment, humidity, high temperature, which happens to be just the same conditions as before. So if you want your boards to be more resilient to loose joints, ventilate your cabinets. So what can we do to actually fix the issue? Well, of course, inspect the board before you try and do anything, optically at least with a lens, and also get yourself proper reworking tool, and definitely, practice before doing it on the real hardware. Another small issue, which you probably all know, This is just a JAMA harness which you can find on eBay for cheap. Can anybody see the problem here? So the problem is actually here. Why? Because they use just a single wire to bring plus 5 volts. As you have seen on your arcade power supplies, plus 5 volt can drain up to 15 amperes. So if you put one wire there, it will be overstressed, it will overheat, it will behave like a resistor, so it will resist the passage of the current, and thereby drop a little voltage. And by a little voltage, I literally mean 0.2. So if this happens, you will get to have all sorts of obnoxious problems and you will start chasing ghosts. So what to do instead? Wire one single wire per pin. So for plus 5 you will have 4 wires. For plus 12 you will have 2 wires. And for ground you will have 8 wires. And of course also use wires that are big enough, protect the solder joint, and blah blah blah, all the stuff that you already know. If you feel, yeah, but I have no clue about electronics, I never learned about electronics. Well, surprise, surprise, you don't need to. Because the kind of information you need in order to repair a board is actually available on YouTube. Here there are some examples of keywords you can search for, like logic gates, memories, 8-bit microprocessor. You do not need to understand how the part works inside, but how it communicates with other parts. Because most of the work you do by checking that things are not going as they should. So maybe you will spend a couple days on YouTube, and then your understanding of electronics will be infinitely better, for arcade repairs at least. Also, if you don't have them already, invest in some right tools. Soldering station, the soldering station. These glasses are awesome. They cost like 20 euros. And remove all the strain. You need to pull the lamp, or you need to look under the microscope, or you need to use a magnifier manually. They're awesome. Multimeters also cost very little. So if you don't have one, of course, buy one. And the last tool I'm going to talk about are oscilloscopes. Oscilloscopes nowadays have everything you would have not even dreamt of in the 80s. So just buy one, they're very cheap. You can find a used one for 150 euros that does exactly what you need, nothing more, nothing less. This is the ESR meter I was talking about before. So if you happen to have the chance to get one, these are very cheap, get one. Instead of just going by trial and error, it's much better to use a methodic approach. And it's always good to always verify your assumptions before you actually go and act and try and do things. Now, shall we try going a little deeper? This is more or less an arcade board. Of course, there are variations on the theme, and there are boards with more processors or with a different audio circuit, but more or less, it's always the same thing. So you have an audio CPU on the top right, which has ROM and RAM, which are needed for the CPU to work, and it has sound generators it is attached to, and it's driven by some timing that usually is independent from the rest of the board. Then you have the main CPU, which communicates one way only with the CPU, with audio, and tells it play this tune, or play this sound effect, or shut up, and stuff like this. Now the main CPU, of course, also has ROM, RAM, I/O, and all the stuff. And there's this blob on the bottom, which varies from board to board. Sometimes it contains customs, sometimes it contains pulse, but most of the times, especially on the older board, it's full of TTL logic chips. You don't really need to understand how this section works, because if the problem is in there, chances is it's going to be very difficult to repair anyway. But again, like a computer, these has ROMs, RAMs, which are used for different purposes, not to store a program, because it's the hardware that runs them, but they store graphic data, they used as buffers and stuff. And of course, all the chips that are surrounding a given area of this tree is gonna be near that area. So if you have a faulty CPU, you're gonna go check the ROMs that are near the CPU. So if you can keep this diagram in mind when you do your repair, it will be a lot easier, because you can immediately isolate the problem to a section of the board. Now, I will provide you a little bit of strategy, I say the systematic approach, and what are the most common things you should check in order to repair 50% of the issues. Well, here they are. This list is actually doable in something like 5 minutes. Okay? Check for the loose joints, which is the first thing you do. Check for power rails. Check if the crystals are oscillating. Also check the reset signal, that it is rising only when the power supply is already stable. And you can do this with an oscilloscope. And of course, check if the video sync is present. Then the other 20-25 minutes, you can start checking activity on the CPU. For example, all CPUs have some sort of read-write pin. Now, when a CPU is properly working, it is going to try to write to the RAM. If the CPU is crashed, it will never issue the right signal low. So you can, there are exceptions. So you can actually check these few pins first. Of course, you want to check that activity is present also on ROMs and on RAMs. And if anything else fails, well, then you seem to have got a problem, and the first thing you should do is dump your ROMs and check them against what's available on the internet. For me personally, there are two types of boards that I love and I hate. Of course, those are originals and bootlegs. Originals, well, they have value. They are expensive. You can find schematics, but they're full of custom chips. And they're often protected, and they often use more than 2 layers. So they're extremely difficult to repair. On the other hand, the bootlegs, well, they're much easier because they're done on 2 layers with all off-the-shelf parts, but the schematics are not going to match, but they're also not going to be protected against the copy. So I personally love working on bootleg because it's a lot of fun, honestly. So if I didn't lost anyone until here, I would like to show you a couple of repairs I've done and describe the inner workings of some of the circuits I found in my adventures. So this one, well, this is Pac-Man. It's very old hardware, and it implements, more or less in TTL logic, all the features which you know from your beloved Commodore 64. So it has 3 voices. Each voice has a distinct pitch. Each voice has a distinct waveform it can play, so it has a different tone. And it can be controlled separately from the others. So if I may show you, those 2 things here in the middle 2L and 2K, those are RAMs, and quite some peculiar RAMs. These RAMs are 8 bytes each. I mean 8 bytes. It's not 8 kilobytes, it's not 8 megabytes, it's 8 bytes. Specifically, 16 locations by 4-bit each. The CPU, through this circuitry on the left, is storing all this information like volume, pitch, and waveform, and something that's called the counter. I will go deeper in a moment, into these memories. Then the contents of this memory is used by the rest of the hardware automatically. So what happens? We have this counter in the bottom memory 2K. And we have a pitch, or rather an increment value, in the top memory, which is called 2L. What do? The two come together to this chip in the middle, which is 1K, and the values get summed. Why is this? Because if you have a value and you increment it slowly with small values, you get 1, 2, 3, 4, 5, etc. But if I increment by 10, I get 10, 20, 30, 50. It increments very fast. So basically, the higher the pitch, the higher the increment, and you get a ramp of values that are going up, 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 up until the counter is saturated, in which case it will restart from 0. So you get a counter that resets at more or less the frequency that you want it to reset. And surprise, surprise, this thing is, of course, stored in the latch that's after that, and fed back to the memory so the value can be stored again. Now, this mechanism is basically an FM synthesizer. Actually, this board is a wavetable generator. I mean, then this is way before the Sound Blaster happened to be in the market, because this PROM memory in 1M is your wavetable, ladies and gentlemen. So it contains waveforms, and via the registers that are there, you select which waveform you want on the top lines, and on the bottom lines you select which sample of the waveform you want. The value is then put to the output, where it is stored in the final latch together with the volume. The resistors, which are just after that, so I'm talking about this section here, convert that to an analog signal, which then gets volume controlled and then fed to the amplifier. And this is done entirely with extremely cheap TTL circuits. This is an engineering marvel on its own. Second board I want to show you is something really fun. I fetched this Gemini Wing board from eBay. And as you can see, there's a lot of missing components in there. Why is this? Well, because the bootleggers made so huge mistakes in the PCB that they decided, okay, let's not mount all the parts and let's sell it anyway. As a result, the digital samples are completely missing. So I said, okay, challenge accepted. I needed to know what parts were in there, and a friend of mine showed a photo of a board he has, which is the later version and has all chips populated, so I had the list, but I still needed to find the problem. So I had to entirely reverse engineer this section, which is interesting how it works. So basically, very simple, this is a portion of circuitry to which you can set a start address in the sample memory and an end address. And when you issue the play command, it will cycle all the addresses, and the ROM would therefore output the samples that then get converted and fed to the amplifier. So basically, the bootleggers had shorted A9 and A10, and they had also misconfigured the sample player. So basically, this board wouldn't work ever. I had to fix the problem, then fit all the parts. That worked. but not completely. I had the samples in level 4, which were not playing correctly. So what I had to do was to create a small extension board that would patch the circuitry even farther. So that, so the problem is, what happens is that the CPU can start playing another sample, another sound effect, before the one that was playing before was even finished playing. In this case, the circuitry gets haywire and all hell breaks loose. So this little patch board over here ensures that the circuitry gets reset every time you ask it to play another sample, no matter if it's playing something. And this is the complete result. The board is worth less than 50 euros, but it was a lot of fun, and it plays samples correctly. Now this one, instead, it's Donkey Kong. And this is a very funny board. Now, the customer said, well, I have accidentally wired the plus 5 volt to what it's actually should have been minus 5. Okay, not a problem. Usually minus 5 volt is used for analog signals, so who cares? Except this wasn't true, because these two memories over here, they are RAMs, but they're special RAMs. They are ECL RAMs, emitter coupler logic, which means they get supplied with 0 volt and minus 5 volt instead of 0 and plus 5. So basically, he reverse polarized the RAMs and fried everything. So the RAMs were broken, replaced them, and everything worked again. But the funny thing about this is that in order to forcibly use these memories, Nintendo has gone all the way of adding a lot of conversion circuitry around the board just to be able to use these RAMs and not take something else which was readily available on the market. So all the gates over here, over there, and there on the top are ICs that Nintendo needed to add just for this purpose. So why? Please, why? So a couple of tools that I developed for myself because I couldn't find anything similar on the internet. The first one is this, is a logic comparator. You know the HP one, everybody knows about it. If you search for a used HP logic comparator, it costs like 300 euros on eBay, provided you find it. I said no, actually I want it cheaper, and I want to make some modifications to it because I want to handle more integrated circuits and more stuff. So basically this thing here handles until 20-pin integrated circuits, which the HP can't. And you can use it creatively to do things the HP was never meant to do. Like you can test 2114 RAMs, for example, and you can compare them to a working set. This other board seems like an EPROM programmer, but it actually isn't. It's made of two boards, one on top of the other, and you cannot see the bottom one, of course. So basically, on the socket you see there, all pins are identical, so you can select which pin is going to be +5 supply, which pin is going to be ground, and which pins are going to be inputs and outputs. So basically, everything that has up to 32 pins and is powered from +5 volt can be tested with this thing, which means you can test RAMs, you can test TTL logic circuitry, keeping them under test continuously to see if they fail later, etc., etc., etc. And when I will want some more function, I will just replace the top board with something else and change the personality of the tool. I want to talk just a little bit about emulation, and then I'm done. Of course, everybody in the world uses MAME to play games. We arcade enthusiasts know that this is not actually the main purpose MAME has been invented for. And that's because they actually wanted to create a tool that would be storing information about the boards that we repair. So it's an invaluable source of information. You can find, it is able to identify all your ROMs that you dump. It has a debugger, so you can take the ROMs that you dump from the board, put them in MAME, and debug what is happening on your ROMs, on your board. And it has also a very friendly community. You can ask information and they will provide it to you. Also, another important thing is that the source code is freely available, so you can look and check what's inside those custom chips that you have on the board and you have no idea about. There's source code, you can read and see and try and understand what the chip does. And most often these things are commented very good, so you can just read the English text and make yourself an idea. So why should you contribute? Because it's mutual help. The more information they have, the better the emulation becomes. The better the emulation becomes, the deeper you can compare your hardware with MAME and see if something doesn't work. How do you contribute? Well, there are tons of ways. You can, for example, donate custom chips which you cannot use anymore because they are on a broken board. You can dump your ROMs and send them to the MAME team so that they can emulate a new game or a new version of it. And of course, you can access their GitHub repository and provide your own code and have it submitted into the MAME distribution. And of course, if you are there using MAME, why not report any bugs or discrepancies against a known board that you see that's working? So that was really quick. I tried to condense all the stuff because I didn't want to lose my audience. I'm done. Thank you very much. Are there any questions? No questions? Okay, then thank you so much.